Today we're going over the properties of exponents. So we have this foldable. We're going to go through all of the properties on this left side, and then we're also going to go ahead and go over the level 1 practice problems. So each of these are laid out to where they tell you the name of the property, and they also show you exactly what's happening, and then have at least one practice problem. So product of powers, product means multiplying. When you have two things multiplying, they have the same base. What I mean by that is they're both x's. That's the base. So when you're multiplying with the same base, you add the exponents. So same base, multiplying, so you're going to add the exponents. And remember, when we're doing notes, it's good to go ahead and actually write what's happening. So if you go back and you're confused, you can kind of see what you did to get the 11. So 3 plus 8 is 11, and so that's how I get x to the 11th. Now, when it is a power to another power, so you have a to the m raised to another power. When it's like that, you multiply the powers. So x to the 4th to the 3rd power, you're going to multiply the powers. 4 times 3 is x to the 12th. All right, this is called power of a product. So you have things multiplying in parentheses being taken to a power. What happens is that power goes to everything in the parentheses. So it becomes b to the m times c to the m. So on this one, you have three things multiplying. So you're going to take the squared, you're going to put it to everything in the parentheses. The biggest mistake is people don't put it to the 5. So it does need to go there. So it's going to be 5 squared, x squared, y squared. And 5 squared is the same as 5 times 5, which is 25. So 25x squared y squared is what that is simplified. Okay. Quotient of powers is when you have the same base. See how they're both a base of d, and they have exponents. They can be the same or different exponent. It doesn't matter. You take the top exponent and subtract the bottom exponent. So m minus n. So the reason this works, just to kind of show you real quick, is if you had something like x to the 5th over x to the 3rd, the reason you subtract is x to the 5th is x times itself 5 times, x to the 3rd is x times itself 3 times. So then they cancel out, and you're left with just x times x, which is x squared. But a much easier way to write this would be just to subtract 5 minus 3, and you get x squared. Now what happens when the bigger number is on the bottom? There's a couple different ways to do this. We're going to come back and refer to the second way. I'm just going to show you the first way now. So if this was the case, then you'd have 3 x's on top and 5 x's on bottom. And what I do is I go ahead and subtract 5 minus 3. I still get x squared, but it has to go on the bottom because that's where the 2 x's were. So what I think about in my head is, well, the bigger power is on the bottom. So essentially the leftovers after canceling will still be on the bottom. And that's why x squared is on the denominator. So I still do 5 minus 3 to get x squared. But then I notice that the larger power is on the bottom. And that's why x squared is on the bottom. So let's look at that with some examples. So we have x to the 10th over x squared. We're going to do 10 minus 2 and get 8. And since the larger power is on top, x to the 8th is on top. Now on this one, same thing. We're going to do 10 minus 2 and get 8, so x to the 8th. But the larger power is on the bottom, so my answer is going to be 1 over x to the 8th. And just kind of picture in your head, well, I have 10 x's on the bottom and only 2 on top, so my leftovers should be on the bottom, and that's why that works. Power of a quotient is very similar to power of a product, how we distribute it into everything. Same thing on a quotient. If you have a fraction inside of parentheses, the m is outside of the power. The power has to go to everything in the fraction, okay, in the parentheses. It gets distributed in. So like on this one, we're going to have x to the 5th over, we're also going to have 2 to the 5th. And y to the 5th. Lots of people forget to do the 5th power to the 2. So x to the 5th over 2 to the 5th power is 32, and then y to the 5th. And that would be our answer. Okay, Negative exponents just create reciprocals. So like if you have a negative exponent, g to the negative m, the negative moves it down to the bottom of a fraction. So now it's g to the m. It's no longer negative because it has been moved. So for example, on this one, x to the negative fourth, the negative moves it to the bottom of the fraction. So now it's 1 over x to the fourth. Notice it's now x to the positive 4. Because it's been moved, the negative is gone. So what happens when you have multiple negatives? If you have h to the negative m on the top of a fraction, it moves to the bottom. J to the negative n on the bottom moves to the top. It's a reciprocal. It changes where it is. So here, the x does not have a power, so the x stays where it's at. Nothing changed. The y to the negative 3, the negative moves it down to the bottom. So now on the bottom is y to the third. It's no longer negative because it's moved. Z to the negative fifth, the negative moves it up to the top. So now up here you have a z to the fifth, no longer negative because it has moved. So that's where I was going to mention that on this one that I had showed you when we talked about, oh, there's 2 different ways to do this one. If you just subtracted the top number minus the bottom, you'd get x to the negative 2, and then that would move down to the bottom and get you x squared. So on this one, there's 2 ways to look at it. They both get 1 over x squared. You can think of it as subtracting 5 minus 3 and then being like, well, the bigger power is on bottom, so that's why x squared's on the bottom. Or you can think of subtracting, if you go consistently, the top power minus the bottom power, then you get negative 2, and that's what tells me it goes on the bottom. So either way, same answer, just 2 ways to look at it. Okay, the 0 exponent, anything to the 0 power is 1. So x to the 0 is 1. On this one, you have this whole parentheses to the 0 power, so everything in the parentheses turns into 1 because the 0 is outside of the parentheses. And then the identity property, anything to the 1 power is just itself. You don't have to write the 1 power. So when it's x to the 1, that's the same as just x. If there's no power written, it's understood that there is a 1 right there. And that is our notes on this. We'll come back with another video to do the follow-up practice problems.